Hi everyone, I know we're asynchronous today, so I just wanted to go through and make a video to try and work through the class problem with you. If you hear a squeaking sound or any clutter in the background, I apologize. I have two beautiful puppies that hopefully won't appear. I have a green screen, so you can't see them, and I can't put anything cool on it. So for the in-class problems, there are 7 in total, I believe. And for problem 1, we are given 2 right triangles here. And look back and you'll remember theorem 4.9 that you went over in your videos the other day, the hypotenuse leg congruence. And it says that if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and corresponding leg of another right triangle, then the legs are congruent. And we're going to abbreviate that with HL. So a tip, if you see right triangles, you should always try to go for HL first. It's not always going to work, but it's a good first step into solving the problem. So if you look, these two triangles are set up almost exactly like the examples down here. They even have the same tick marks, they're just a little bit angled. So these are right triangles, and the hypotenuses are congruent, as you can see right here. We have two congruent hypotenuses and two right angles. And in addition, the third legs, or the corresponding legs, are also congruent. So these two triangles are congruent by HL. All right, so for problem 2 then, we are given these two triangles. Now, I know we said before that we're going to look for hypotenuse-like congruences because they're right triangles. So we're starting off, they are both right triangles. Get my pen so I can highlight it. So we have the right angle here and a right angle here. They both have a corresponding leg congruent. So that is this leg right here on both triangles. However, the problem with these is we don't know if the hypotenuses are congruent. We're not given any kind of tick marks on either of these to show that they're congruent. So these two triangles are not congruent by HL, but we don't have any other information. We're not given parallel lines. We're not given perpendicular lines. We're not given midpoints. So we don't have enough to determine whether the triangles are congruent at all. So these two triangles are not congruent. I'm sorry, I clicked away. I was trying to make my webcam a little bit smaller. So for problem 3, we are given these two triangles. Now, what's important to note here is we have one right angle, and that is this angle right here. And we know that perpendicular lines form corresponding adjacent right angles. Now, we're not told that these two lines here are perpendicular. However, we do know that because straight angles have to be 180 degrees, that this angle over here must also be a right angle right there. So we are given one right triangle, and because straight angles form 180 degrees, we know the other angle must be a right angle. So because we have right angles, we're going to be looking for hypotenuse leg. So because these angles are right angles, these are both right triangles. The corresponding legs are congruent. That's these two legs right here. But the hypotenuses aren't congruent that we know of. So these two triangles are not congruent by HL. However, the shared side is congruent to itself by the reflexive property, and therefore the triangles are congruent by SAS. So for problem 4, we are given these two triangles. And again, we see that they are right triangles. So we know we want to look for HL first. The right angles are marked down in the corners here. The triangles have a corresponding leg congruent. That is the legs highlighted here in blue. And that's the best I've drawn a straight line in a while with a mouse. And the triangles have a congruent hypotenuse. And that is right here in green. Very dull colors. Probably should pick something a little bit more lively. And so these two triangles, because they are right triangles, they have a shared corresponding leg and the hypotenuses are congruent. Then they are congruent by HL. So problem number 5, everyone's favorite, proofs. Should probably erase my markings from before. So we are given that angle W and angle Y are right angles, and that WX is congruent to YZ. So the first thing that we want to do whenever we are given that kind of information is we want to make our tick marks. So there's our tick marks to show our segment congruence, and here are our arcs showing angle congruence. And what we want to prove is that WZ is congruent to segment YZ. Now we know before we do anything involving segment congruence, we have to show triangle congruence. We did that all of last week in the proof puzzles. So it's always you have to show triangles are congruent and then show sides are congruent. So we are given that angle W and angle Y are right angles. The reason for that is given. And then we're given that triangle XWZ is a right triangle and triangle XYZ is a right triangle. And we know that because that's the definition of a right triangle. If there's a right angle in the triangle, then it is defined as a right triangle. So we've done all we can do with that initial given information. We're then given that segment WX is congruent to segment YX. That's in the given information. So where do we want to go from there? Take a minute, think about, pause the video, write it down. Our next step, because we have our right angle congruent and our corresponding side congruent, we are looking for the hypotenuse because we're dealing with right triangles. We said that was going to be the first thing that we always tried here. And we know that segment XZ is congruent to itself by the reflexive property. I'll put that in a different color. Let's try purple. I haven't done purple. And remember, when a segment is congruent to itself, we always mark it with an X. So then our correspondence of, I'm going to get rid of all my markings here, triangle XWZ is congruent to triangle what? So we're starting here on the short side. We're going down the side that had one tick mark to the right angle. Then we're following the long side and then back up the hypotenuse. So triangle XWZ is going to be congruent to triangle XYZ. And we know that by hypotenuse leg in statements 2, 4, and 3. So in statement 2, we're given definition of a right triangle. 4, we're given the hypotenuse, and 3, we're given the side congruence. And then we know that we're looking for our last segment. Segment WZ is congruent to segment YZ, and that is by CPCTC. And for those of you who don't have it written down yet, write it down. CPCTC is corresponding parts of congruent triangles are congruent. All right, so for problem 6, we are given that segment TQ is perpendicular to segment RS. and that Q is the midpoint of RS. And we want to prove that segment TQ bisects angle TRS. So we want to prove that segment TQ right here bisects TRS. I probably should have done a better color than that because it's blue, but we'll deal with it. So this is a little bit different than any problem we've done before because we haven't been asked to prove an angle bisector yet. So we're going to work through it step by step. So what we have at the beginning is TQ is perpendicular to RS. And what do you know about perpendicular angles? Perpendicular segments and the angles that they form. Well, we know that perpendicular lines form congruent, adjacent, right angles. Since both angles are 90 degrees, they're congruent and they're adjacent. They're on each side. We saw that back with problem 3, I believe it was, where we had one right angle and then we had to insert the other right angle there. And that's all we can do with the information there. So we have Q is the midpoint of RS. And because Q is the midpoint of RS, we then know that segment RQ is congruent to segment SQ, and that's by the midpoint theorem. So now we can take I'm going to erase these markings here. We'll get to them then. We know that segment RQ is congruent to segment SQ. Let me draw some angle ticks here. Angle 3, or angle arcs there, I'm sorry, is congruent to angle 4. And then we know segment TQ is congruent to itself because these two triangles share a side, and whenever the triangles share a side, we know that the segment that they share is congruent to itself, and that is by the reflexive property. So we want to draw an X there. And then we know that triangle, let me see if I can find a different color. Triangle RTQ, we're going to start at the outside here. We're going to go up the long side, down the shared side, and then across the side with one tick mark, is congruent to triangle, I'll go with yellow. We're going to do this in there. We're going to start at S. We're going to go up the long side, down the shared side, and then across the side with one tick mark. So we went to STQ. So we know triangle RTQ is congruent to triangle STQ. And that is by SAS. That is in 2, 4, and 5, or 4, 2, and 5, I'm sorry. Right here we have our S, we have our A, and we have our S. Remember, these on the side are not important so much as it is to have these here with the 4, 2, 5. It's a good check for you, and it's a good check for us to make sure that everything is where it needs to be. So now we know that angle 1 is congruent to angle 2 by CPCTC. And we know that this is true because if angle 1 is angle 2, then it means that TQ bisects RTS by the definition of an angle bisector. All right, and for our last problem, problem 7, we are given that segment EF is perpendicular to segment EG, and that segment HG is perpendicular to segment EG, that EH is congruent to GF, and we want to prove that angle H is congruent to angle F. We will work our way down the given information, starting with the EF is perpendicular to EG, and HG is perpendicular to EG. That reason is given. What can we conclude about segments when they're perpendicular? We know that HGE is a right angle, and that FEG is a right angle. So FEG is a right angle, and HEG is a right angle. And the reason for that is given. Its perpendicular lines intersect to form right angles. And because we have right triangles, we now know that triangle HGE is a right triangle, and triangle FEG is a right triangle. and that is by the definition of a right triangle. Now remember, we have right triangles, so we're going to be looking for a hypotenuse leg. We are given that segment EH is congruent to segment GF, and that is given. Therefore, we have the hypotenuses of these legs congruent, so we would be looking to show a corresponding side. We can't show segment FE is congruent to segment HG because we don't have the information to conclude that. However, these two triangles share a side, and that is segment EG is congruent to segment EG. So it's congruent to itself. That is by the reflexive property. And then triangle HGE, I'm going to try and do this in blue. HGE is going to be congruent to triangle. We're going to follow it the same way. So we start at the outer corner here and we move to the right angle. FEG. And that is by hypotenuse leg seen in statements 3, 4, and 5. So we have the right triangle. We have the hypotenuse in step 4, and then the corresponding congruent leg in step 5. And then we know that angle H is congruent to angle F by CP CTC. So we hope you enjoy the rest of the snow day. Work hard, stay safe, go build a snowman. We'll see you all tomorrow or Thursday. A wonderful day, everyone.